Now we'll examine Identity and Access Management, or IAM, which serves as a framework of policies or applications within a system to control user access. Now, this framework is crucial for securing digital environments, and it encompasses three main objectives that collectively govern how users interact with systems. First, identification is the process by which a user claims an identity, and this user is not always a person, it may also be another device or system. Second, authentication follows, involving the act of verifying or proving the user's claim to an identity. And finally, authorization, the final objective, entails granting a user access to a system or resource based on verified identity and permissions. Identification can be achieved through various means, for example, providing a correct username or obtaining a digital certificate that binds the user's identity to a cryptographic key. Also by using a token, which is usually generated on a physical device that issues a unique code. Identification can be tested and verified by employing an SSH secure shell key held by the user, or utilizing a smart card embedded with a scannable authentication chip assigned to the user. Identity proofing, a critical step in the identification process, verifies a user's identity during initial registration. An example of this is requesting the documents required when opening a new bank account. A personal attribute is another identification factor that refers to a specific characteristic of an identity, such as a name, email, password, or address, providing additional context for the authentication process. Authentication involves authentication factors, which are pieces of evidence used to prove a user's claimed identity. This includes a username, providing a password, supplying a PIN, or offering another type of code. The authentication process ensures that unauthorized users are prevented from accessing protected systems or resources. An authentication protocol facilitates the secure transfer of authentication data between two parties. Some examples include the Password Authentication Protocol, or PAP, and the Authentication Challenge Handshake. Authorization focuses on granting access permissions to a subject, such as a user, device, or system, who seeks access to the resource or system desired, also known as the object. This process does not involve verifying or proving a user's claim, rather it involves determining and providing appropriate access to the user. An access control model establishes a set of technology-independent rules for controlling the subject's access to the object, ensuring that access is granted to the subject rather than directly to the object itself. Let's talk now about authentication factors. Authentication factors refer to the type of evidence that a user provides to prove their claimed identity. And there are 5 distinct types of authentication factors. The knowledge factor includes something the user knows, such as a password or PIN. The possession factor involves something the user owns, like a smart card, mobile device, or security token. The inherence factor leverages something physiologically unique to the user, such as a fingerprint, voice, or retina or iris scan. The location factor uses the user's geographical position, tracked via IPS or GPS, for example. Finally, the behavior factor relies on user-specific actions such as gestures, movements, drawing patterns on a screen, or typing patterns to unlock access. Moving on to single-factor authentication, or SFA, single factor represents the most basic form of authentication and is most often implemented using a password, smart card, or similar method. Then we have a two-factor authentication system, which combines 2 forms of authentication, such as a password or text message with verification code. Two-factor authentication is a subset of multi-factor authentication, or MFA. A multi-factor authentication combines 2 or more authentication factors, such as requiring a user's password, a knowledge factor, and a verification code sent to a mobile phone, which is a possession factor, in order to enhance security. Multi-factor authentication factors operate on the principle that using more authentication factors increases security, though it requires balancing system security with user convenience and efficiency. Knowledge-based authentication includes 2 approaches. Static knowledge-based authentication requires a user to answer a set of predetermined authentication questions, with those answers stored for future authentication, requiring the user to provide correct responses again in the future authentication sessions to gain access. These authentication answers, known as shared secrets, are held and stored by the authentication system. Dynamic knowledge-based authentication, or dynamic KBA, generates or compiles questions from public and private records and requires the user to answer queries about updated personal information. These can include information that can be changed or updated, such as an account balance, recent address, transaction history, and sometimes including diversionary questions designed to deceive imposters. Dynamic KBA is considered more effective than static KBA due to its adaptability and reduced predictability. Many authentication methods include the one-time password or OTP, a 6 to 10-digit code often used as a part of a two-factor authentication, which can only be used once. This offers greater security than reusable passwords by preventing voluntary or involuntary sharing and also eliminating the need to remember complex passwords. A one-time authentication password can be generated and used when a hardware or software security token and network connection are available. There are two types of OTPs: time-based one-time passwords, generating using a timer, and secret key that changes periodically without user interaction based on a time step. A time step is an increment of time between 30 and 180 seconds, remaining valid for that duration and generated by either a software application or hardware device. An OTP remains valid until it is used for authentication. Google's Authenticator, for instance, uses either a time-based one-time password or an HMAC-based one-time password as part of its two-factor authentication process. An HMAC one-time password key, also known as an HOTP, uses an algorithm to generate a dynamically changing code. A security key or a password key does not store a password or passcode, such as an OTP, on any network or device. This makes it more secure than methods relying on SMS or email for OTP delivery. Software-based OTPs are generated by an authentication application, also known as a software token, which produces one-time password codes. However, this application cannot generate a valid OTP for any authentication server. It must be configured for use with a specific authentication server. The authentication server sends a secret key to the authentication application, constituting a possession factor, something which the user owns, rather than a knowledge factor, which is something the user knows. This secret key enables the application to generate one-time passcodes for all future authentication requests to that server. What is a software token? Software tokens refer to the software application generating an OTP in various forms. It can also be called a token key or password key. A hardware device like an RSA key fob generating an OTP can generate a token. Hardware-based security modules enhance device authentication to ensure that unauthorized operations are not performed on data and systems. Two hardware-based technologies support this process. First, the Trusted Platform Module, or TPM. This is a secure processor performing cryptographic operations. It can be embedded on or installed in a computer motherboard with a TPM port, featuring a burned-in RSA key pair for authenticating hardware devices. A TPM can store cryptographic keys, passwords, and certificates. It is ideally tamper-resistant and helps prevent unauthorized modifications to firmware and software as part of a secure boot process. It is used in full disk encryption, or FDE, where an operating system encrypts an entire drive, including all user system and files. The second technology, the Hardware Security Module, or HSM, is a tamper-resistant external device or plug-in expansion card that provides cryptographic services capable of storing a hardware device's certificate. It is used for real-time authentication and authorization of credit and debit card transactions and payment card industry, for example. An HSM contains one or more cryptoprocessors, which are basically dedicated microprocessors performing cryptographic operations like encryption. We also need to know what a secure enclave is. A secure enclave is a tamper-resistant hardware component isolated within a system or device that provides a secure environment for cryptographic operations. It ensures that sensitive data remains encrypted and inaccessible to other software, including the operating system. This enables the devices to comply with data protection regulations, such as those for digital rights management and secure payment processing transactions. Biometrics involve measuring unique biological characteristics to authenticate and verify a user claiming an identity. Biometrics can be categorized into physical traits such as fingerprints, hand palm prints, face, iris, retina, and vein image patterns, as well as DNA and behavioral traits such as voice, gait, signature, and keystroke patterns. A biometric factor, also called an inheritance factor, is something inherited biologically. There are 7 current biometric factors, which include finger scans, capturing the pattern of ridges and valleys using optical, capacitive, or ultrasonic scanners. Also retina scans, which focus on recording blood vessel patterns in the back of the eye with low-energy infrared light. Iris scans by capturing the color and pattern around the pupil with video camera technology. Facial recognition, which measures distances between facial features like the nose, cheeks, or ears, using a thermal camera specifically. Voice recognition, recording pitch patterns, rhythms, and sounds of a person's voice with a microphone. Vein pattern recognition, recognition, which involves recording blood vessel patterns with an infrared scanner, and gait, capturing muscle movements during walking patterns. Biometric systems are subject to errors defined by four key terms. 1. The false rejection rate, or FRR, is a type 1 error, where valid biometric measures are rejected. 2. The false acceptance rate, or FAR, is a type 2 error, where invalid biometric measures are accepted. 3. The crossover rate, or CER, also known as the equal error rate, which is the point at which FRRs and FARs are equal. This, by the way, serves as the most important metric for comparing the accuracy of biometric systems, where the lowest CER indicates the most accurate system. And the fourth term is the relative operating characteristic graph, or ROC, which illustrates the trade-off between false rejection rate and false acceptance rate. As a biometric system's sensitivity increases, the false rejection rate also increases, while the false acceptance rate decreases. And as the likelihood of false rejections decrease, potential for false acceptances rises. The efficacy or effectiveness of a biometric system is measured by its ability to minimize false acceptance and false rejection rates. Authentication protocols include two main types: the Password Authentication Protocol, or PAP, and the Challenge Handshake Authentication Protocol, or CHAP. The Password Authentication Protocol is used to authenticate a client to a server over a point-to-point connection, employing a two-way handshake protocol initiated once at the beginning of the connection. It sends an unencrypted password from the client to the server, which does not encrypt username or passwords, but renders it somewhat insecure. The server sends an authentication acknowledgement, or ACK, to the client if the username or password are correct, or it sends a negative acknowledgement, or NAK, if either is incorrect. The Challenge Handshake Authentication Protocol, CHAP, provides ongoing authentication periodically using a three-way handshake where the server sends a randomly generated challenge string to the client. This combines that string with a secret hash value shared with the server using a hash function to compute and verify the response. This type of authentication protocol ensures continuous security. Kerberos is another type of authentication protocol. It enables a user to access a network service using a ticket-based mechanism. It involves three entities: a server hosting a service, a client accessing the data, and a key distribution center, or KDC, which is a trusted third party comprised of an authentication server, which authenticates the user. The key distribution center sends a ticket granting, or TGT, after validating the user's identity. Then a ticket granting server, or TGS, issues the ticket to the user. The ticket, also called a service ticket, is an encrypted message proving the user's authorization and thereby enabling access to the service for the duration of one authenticated session. A new ticket is required for each subsequent access to the server. The ticket granting server and authentication server are the two components of the key distribution center, facilitating secure ticket-based authentication across network services. Now let's discuss the Authentication Protocol, or EAP. The Extensible Authentication Protocol serves as an authentication framework rather than a specific protocol. It is designed to transport various authentication protocols and define the format of authentication messages. It supports multiple authentication methods, including certificate-based, password-based, and multi-factor or mutual authentication. The EAP facilitates communication through four types of messages. First, an EAP request sent from a server to a client requesting information. Second, an EAP response sent from a client to a server in reply to the server's request. Third, an EAP success message sent from a server to a client if the client's authentication is successful. And fourth, an EAP failure message sent from a server to a client if the authentication fails. Four methods are commonly used with EAP authentication. 1. Extensible Authentication Protocol Transport Layer Security, or EAP-TLS. This is an authentication protocol that employs transport layer security, or TLS, by issuing certificates for mutual authentication, requiring both a server and a client certificate. 2. Extensible Authentication Protocol Flexible Authentication via Secure Tunneling, or EAP-FAST. This is an authentication protocol that uses a Protected Access Credential, or PAC, to establish a TLS tunnel between a server and a client, with Protected Access Credential, PAC, generated by the server and holding client-specific information. 3. Extensible Authentication Protocol Tunneled Transport Layer Security, or EAPTTLS, is an authentication protocol that uses TLS and a server certificate to create a secure tunnel between server and client, allowing the server to authenticate the client through the tunnel using any protocol, including legacy password methods like PAP, though it does require a server certificate, but not a client certificate. 4. A Protected Extensible Authentication Protocol, or PEAP, is an authentication protocol that encapsulates EAP messages within an encrypted and authenticated TLS tunnel, requiring a server certificate but not a client certificate. IEEE refers to the Institute of Electrical and Electronics Engineers. Its goal is to provide the go-to online presence for security and privacy for cybersecurity professionals. IEEE Standard 8021X is an IEEE standard for port-based access control. It is used for passing EAP messages over wired or wireless networks with EAP over LAN, or EAPOL. The IEEE 8021X authentication process involves three entities. 1. A supplicant, which is a user or device seeking to authenticate a network. 2. An authentication server, which authenticates the supplicant and makes access control decisions. And 3. An authenticator, which is a device acting as a proxy for the supplicant, controlling communication with the authentication server. IEEE 8021X uses EAP to facilitate interaction between these entities. In this framework, an EAP request is sent from an authenticator to request a supplicant's credentials. An EAP response is sent from the supplicant to the authenticator to provide the supplicant's identity. An EAP success message is sent from the authenticator to the supplicant if the authentication succeeds. And an EAP failure message is sent from the authenticator to the supplicant if the authentication fails. The Remote Authentication Dial-In User Service, or RADIUS, is a networking protocol providing centralized authentication, authorization, and accounting, or AAA services. It combines authentication and authorizations while using UDP port 1812 for these services and UDP port 1813 for accounting. Windows Server 2019, for example, can be configured to use Radius for authenticating and authorizing users. The Radius protocol facilitates a message exchange between a Radius server, which provides authentication and authorization services, and a Radius client, a network access server, or NAS, acting as an intermediary for a user's connection request to the server. The Radius client functions as an access gateway between untrusted external networks like the Internet and trusted internal networks such as a company or personal server. In Radius authentication, a user connects to a Radius client which prompts for the credentials and sends an access request message containing those credentials to a Radius server. The server then validates the credentials using an authentication protocol like the Challenge Handshake Authentication Protocol, or CHAP, combining authentication and authorization services. It only encrypts the user's password, leaving the other AAA packet contents unencrypted. The Radius server responds with an access reject message if the credentials are invalid and disconnects the user's session. It may generate an access challenge message if additional information such as a PIN is required. If the credentials are valid, then it may generate an access accept message to start the user's session. A user can also send a disconnect message to the Radius client, stopping the session intentionally. Terminal Access Controller Access Control System Plus, or TACACS Plus, is a proprietary networking protocol developed by Cisco for centralized AAA authentication, authorization, and accounting services, which supports multi-factor authentication and separates authentication, authorization, and accounting services. It is commonly used for authenticating administrator accounts to network devices like switches or routers. TACACS Plus uses TC port 49 and encrypts the entire content of each AAA packet, unlike Radius, which only encrypts the passwords. A TACACS Plus client, such as NAS, obtains a user or device's credentials and sends an authentication request to a CACACS Plus server, which contains authentication information and responds with an accept message if credentials are valid. A reject message is sent if they are not valid, or an error message if the network error occurs during authorization. In review, an accept message is sent by TACACS Plus server to a client if user credentials are valid, a reject message is sent if they are not, and an error message indicates a network error during authentication. Security Assertions Markup Language, or SAML, is an XML-based standard for exchanging authentication and authorization information, providing single sign-on, or SSO, for web-based applications. SAML is commonly used by web portals, enabling a user to log into multiple systems with a single identity. SAML is used for exchanging authentication and authorization data, with an IDP managing identity information and an SP service provider offering services, while an SSO single sign-on facilitates authentication. When a principal requests a service from an SP, the SP requests the principal's authentication and authorization information from an IDP. The IDP then responds with a SAML assertion and a digitally signed XML document containing statements about the principal. This enables the SP to make access control decisions. SAML includes three types of assertion statements. First, an authentication statement asserts that a principal is authenticated at a specific time using a specific method, called an attribute statement. The attribute statement confirms that a principal is associated with a specific attribute and name-value pair. This then creates an authorization statement, which verifies that the principal is permitted to perform a specific action on a specific resource. To review, an IDP creates, manages, and maintains identity information for a principal. A service provider, SP, provides service to the principal. An SAML authentication statement asserts a principal's authentication time and method. SAML attribute statement associates a principal with a specific attribute, and a SAML authorization statement permits a principal to act on a resource. Now let's look at OpenID. OpenID is an open standard protocol for decentralized authentication. It allows a user to log into multiple websites without separate credentials for each, enabling a client, such as a website or application, to verify a user's identity without managing credentials, without relying on a central authority. An OpenID identity provider, or OpenID IDP, is a website managing a user's identity information. Some examples included are Google and Facebook's authentication servers. An OpenID acceptor, or relaying party, is a website accepting OpenID authentication. A user creates an account with an OpenID identity provider, or IDP, and uses it to sign into an OpenID acceptor, which redirects the authentication request to the IDP, confirming the user's identity. OpenID does not mandate a specific authentication method, so it allows for legacy passwords, smart cards, or biometrics. To review, a user creates an account with an OpenID IDP which manages identity information, and an acceptor redirects the user's request, confirms identity, and then accepts the request through the OpenID authentication. OAuth is an open standard authorization protocol. It enables a user to grant a client, such as a website or application, access to the user's information at other websites without sharing credentials. It is designed for use with HTTP, providing secure delegated access. During the OAuth process, an authorization server issues access tokens to a client with the user's approval, allowing the client to access a user's resources hosted by a resource server. Some examples include Google and Microsoft using OAuth for sharing account information with third-party applications. Interoperability ensures consistent credentials and protocols across platforms, enhancing efficiency and security. An example of this is seen in healthcare systems, using a single login across hospitals and clinics to access client records and information. Account policies are policies that define how an account should be created, used, maintained, disabled, or removed, and they are protected by password verification in most cases. Password policies sets rules for password properties, including three common types. First, a password complexity policy defines requirements for passwords' length and character types. This helps prevent future brute force attacks. Second, a password history policy specifies how often an old password can be reused, preventing password reuse and repetition. And third, a password age policy, also known as password lifespan policy, determines how often a password should be changed. This helps to limit the time a compromised password can access an account. A password vault or password manager is a software application used for storing, managing, and securing passwords. It enables complex password use without the need for memorization. To review, a password age policy may require changes every 21 days. A password complexity policy may mandate one lowercase letter 8 or 10 minimum characters, and 3 uppercase letters, or other requirements. And a password history policy may prohibit reuse of the last 4 passwords when updating your new password. Continuing with the concept of listing things numerically, a computer user is associated with computer account containing information and permissions with 5 account types. 1. A user account or end user account is assigned to an individual accessing a computer resource. 2. A privileged account, also known as an administrative or root account, is assigned to a system administrator with full system control. This is used for administering and maintaining resources, such as the root account in a Linux or Unix system, or the administrator account in a Windows system. 3. A shared account, also known as generic or group account, is accessed by multiple users, sharing credentials to access the same resources. 4. A guest account is assigned to temporary users with limited privileges. 5. A service account is assigned to an application or service. It is not for user interactive login.